Hello and welcome to this solution video of paper 42 winter 2024. If you like this video, please give it a thumbs up. I think I'm the first person to solve this paper anywhere in the world. And please share this video with your friends and subscribe to Math United. Let's get started with question number 1, which has given us a VT graph, and it says that from 0 to 4 seconds it accelerates to v meters per second. Then after 4 seconds to 10 seconds it decelerates, and this is the deceleration, which means the gradient of this particular line is negative 5 over 3. Just keep in mind. Okay, then it stops here. So keep in mind that even if the direction of the graph is changing here, the object is not changing its direction. It is still going away. If it was a distance or displacement time graph, the graph will still go up. It stops here and then changes its direction and stops after few seconds at t time. Okay, so maximum speed is minus 3 meters per second backwards. Find the value of v. So since I've already said that the gradient of this line is minus 5 over 3, if I know the coordinates of these 2 points, I will find v. So I don't know, but I can see that this is 10, 0, and this one is 4v, right? And now we can find easily v by writing the equation of a gradient, which is y2 minus y1 over x2 minus x1, and we know this is equal to minus 5 over 3. So v over minus 6 equal to minus 5 over 3. V comes out to be minus 5 times minus 6 over 3, cross multiplication, that goes minus 2. So v comes out to be 10 meters per second. This v is 10 and the coordinates are 4, 10. Okay, now let's see what is the b part. B part says that given that the total distance traveled by the particle from t equal to 0 to t equal to capital T is 68 meters. Find the value of t. Total distance, they said, not displacement, right? Distance means whatever is the area under this particular triangle and this triangle will be added, not subtracted, okay, because it's negative. So displacement will be negative in this case, but we will add the two areas, and let me do that on the left side here. Okay, first this triangle. So what will be the area? Let's call it triangle 1, and let's call this triangle 2. So triangle 1, what is the area of triangle 1? Which will be half base times height. Base is how much? 10. What is height? We just found it, 10 again. So the answer will be 100 divided by 2, 50 meters. So it went 50 meters away from the reference point, from point O, and then after that it started coming back, but it does not mean that it reaches O. Okay, so we know that total distance is 68 meters. That means 50 meters was traveled this way, 18 meters will be traveled backwards. So now we know that the area of T2 is 18. Okay, which will be half base is from 10 to t. We don't know how much is this distance, so we'll write t minus 10 so that we can subtract 10 from t and get this distance. And the height of this triangle is 3, not minus 3, because we want area, we don't want displacement. Okay, so 2 and 18 multiply 36 equal to, and let's multiply 3 with this, 3t minus 30. So 3t will stay here and 30 will go there. 33, no, 36 plus 30, which is 66 equal to 3t, and t comes out to be 66 divided by 3, which is 22 second. That is the value of t. and that's what they asked us. Find the value of t 22 seconds. Question number 2. A block of mass 20 kg is held at rest at the top of a plane inclined at 30 degrees. So let me draw a plane which is inclined at 30 degrees and a block is kept at the top. Its mass is 20 kg, that means its weight downwards will be 20 times 10, 200 newtons. Okay, the block is projected with a 5 meter per second down a line of greater slope. So it is projected. That means someone pushed it and left it. Did not kept its hand or force on it, just pushed it. And the starting position u is 5 meters per second. Starting velocity. Okay, there is a resistance force acting on the block. So there is a resistance this way. As the block moves 2 meters down the plane from its point of projection, so say here, the work done against this resistance is 50 joules. From here till here, this point, this distance is how much? 2 meters. Find the speed of the block when it has moved 2 meters down the plane. So we will use energy formula in this one, which says that work done by the applied force is always the sum of difference in kinetic energy, difference in potential energy, and work done against resistance. Okay, since this block was pushed, no one touched it after that. That means applied force during these 2 meters is nothing, zero. Okay, but there will be a change in kinetic energy, and that will be decided by, that's what they're asking, how much is the speed after 2 meters. So we will write first half m final velocity square minus initial velocity square, which is u in this case, that will be initial velocity, plus mass times g times final height minus initial height, and then plus work done against resistance, which is 50 joules. There is no need to do anything here, and let me not write the unit. Okay, so now since, let me focus this triangle, okay, let me redraw this here. So this distance is 2 meter. This angle will also be 30 degrees, right? So we have to find h in this case from which height it came down. So that will give me initial height. Yeah, it was here and it came down to this level. Let's call this 0. Okay. So hi, which is opposite side, divided by hypotenuse, is equal to sine 30 degrees. Sine 30 degrees is half. So hi equal to 2 multiplies with half, which is 1 meter. That means this particular block came down by 1 meter vertical height. Okay, that's what we'll use here now. Let me use that one by one. 0 equal to half mass of the block is 20 kg. Then we have final velocity, which is, let me write only v to that one, which is asked, but initial velocity is known to us, which is 5 meter per second, plus mass is again 20 times 10 is 200. Final height is 0, it came down, and initial height was how much? 1 meter. And then we have 50. V final velocity is the only one which is asked as a speed here, and we will say that is the velocity. So 2 and 20 cancel, 10. So I'll open this bracket now, 10v square minus 25 times 10, 250, plus 200 times minus 1, which is minus 200, plus 50. So minus 250 minus 200 is 450, and plus 50 will be minus 400, so that goes to the other side. Positive 400 equal to 10 v square, divide both sides by 10, it's gone here. So v will be square root of 40 meters per second. And they did not ask us whether they want it to be an exact or uh, decimal places, but let's convert square root 40 to decimal as well, which is about 6.32 meters per second. This is exact, this is in decimals. Question number 3. A cyclist is riding along a straight horizontal road. The total mass of the cyclist and cycle is 90 kilograms. Okay. The power exerted is 250 watts and the mass is 90 kg. At an instant means at one particular time when the cyclist speed is 5 meters per second, his acceleration is 0.1 meter per second square. So let's say v is 5 meters per second, acceleration is 0.1 meters per second square. Find the value of constant resistance to the motion acting on the cyclist. Okay, so we can say that the mass times acceleration, which is the net force on the cyclist, is always the difference of what is being applied minus the resistive force. Okay, so acceleration is given, mass is given to us, so we'll write 90 times 0.1 is equal to applied force and find the value of constant resistance to the motion. Okay, so they're asking this minus Fr. That means this applied force should be known to us, and we can find this with the help of power. Power is the applied force times the speed at that time, and we have both of them. Power is 250 watt. Applied force we want to find out, but we know the speed at that moment, which is 5 meters per second. Cross multiply equal to applied force, which comes out to be 50 newtons. Okay, so we will write 50 newtons here. That becomes applied force, and now we will multiply this first, so it is 9. This 50 will go to the left side, becomes minus 50 equal to Fr. So minus 41 newtons equal to minus Fr, and resistive force comes out to be 41 newtons. That's what they were asking. Find the value of constant resistance to the motion, 41 newtons. Okay, B part. The cyclist comes to the bottom of a hill. That means he was going or she was going to on a horizontal plane earlier, now goes at the bottom of a hill. So suppose here, okay, and it is inclined at just 2 degrees. Okay, given that the power and resistance of the motions are unchanged, so power is still 250 newtons, not watts, newtons, watt, and resistance to the motion is 41 newtons. So Fr is 41 newtons. Okay, find the steady speed which the cyclist should maintain while riding up the hill. Steady speed means same speed throughout. Okay, so let's say that at this moment the mass is 90 kilograms. That means 900 Newton is the force downwards. So there will be a resistance force in this case, which will be the weight component in this direction, which will be 900 sine 2 degrees. There is another resistance in this, which is 41 Newton. Okay, and there will be an applied force, and they asking what will be the speed, what will be the velocity in this case. Okay, so given that the power remains same, so this power is 250 newtons straight. So can I find applied force which will be in this direction by the cyclist? So 250 power, I will use exactly same equation that I use here. Power is force applied times speed is equal to force applied times speed, and both of them are unknown to us, right? So what will we do? We'll write V here. It will become 250 divided by V equal to applied force. All right, and that's what we are going to use in this particular scenario, which is again MA will be equal to the difference of applied force minus resistive force. Mass is 90 kilograms. Acceleration will be 0. Why? Because they said steady speed, same speed, that means no acceleration, right? Speed is not increasing at all, so 0, equal to applied force, we just got 250 over V, minus resistive force is 41 newtons, right? And there will be 900 sine 2 degree also. So there are two resistive forces, one applied force, which is this. V is the only unknown thing here. So what will I do? This is 0. So I'll take this negative part whole to the left side now. 41 plus 900 sine 2 degrees equal to 250 divided by V. And now cross multiply, V will take the place of these two, and these two will become the denominator on the side, which is 41 plus 900 sine 2 degrees. I'll just place this in my calculator and I'll get my answer for the steady speed they want us to find out. Okay, by the time I use my calculator, I would request you to like this video, share with your friends, because this is the first video on the solution of this particular exam without a marking scheme. So please share with your friends and subscribe to Math United. What I'm getting here is 3.4525 and many more digits, but I will stop at 3 significant numbers. 3.45 meters per second is that steady speed. Question 4. The diagram shows two particles A and B, masses 0.2 kg and 0.1 kg separately, respectively. Okay. The particles are suspended below a horizontal ceiling by two strings, okay, AP and BQ, attached to fixed point P and Q respectively. Okay, the particles are connected by horizontal string also, A and B. Angle APQ is 45 degrees, and that is theta. Each string is light and inextensible. The particles are in equilibrium. Very good. Find the value of the tension in the string AB, this one. All right, so let's try to write all the components of the forces. This is a tilted force, right? This is a horizontal force, so we can just write T1 to this one, T1, okay? And there will be a component on this side of this tension on this particular string, which I will call T2, and then there will be tension in this string, which we call T3. So if this is theta, this will also be theta, right? This one. So there will be a component in this direction for T2, which will be T2 cos theta. This will be T2 sin theta. This similarly will be T1, rather T3 sin 45 degrees. Not theta, because this angle is 45 here. This will be T3 sine, not sine, cos 45 degrees. Okay, now there will be force downwards for this, which will be 2 newtons. There will be force downwards for this, which is 1 newton. Okay, our ultimate question is to find the tension in AB. This T1 we have to find out. Okay, so we can do what? We know most of the things here in this particular part, so we can use that one. So there is a force downwards which is 2 Newton, not Newton, let's say 2, which will be equal to T3 sine 45. And T3 will be 2 divided by sine 45. I'm not evaluating this because this will be used later. Now, if I look at the horizontal forces on this particular body, there will be a force T3 cos 45 to the left, T3 cos 45 degrees to the left, which will be equal to the tension in this string, which will be T1 in this direction for this particular cable. So it will be equal to T1. That's it. There is no other component at this particular body. So T3 is already known as 2 over sine 45 equal to, on cos 45 also multiply by cos 45 equal to T1. Alright. So sine over cos is tan. So it becomes T1 becomes 2 divided by tan 45, which is 1. So 2 divided by 1 is 2. So tension in the cable AB is 2 newtons only. Let's go to the second part. B. Find the value of theta and the tension in BQ. So we want to find the angle theta and BQ. Now we know the tension is 2 newtons in this one. So let me complete that part here. So this T1, which is 2 to the left, it's the same string, right? So tension will be same, will be equal to T2 cos 45. Not cos 45, theta. There is theta. T2 cos theta and T1 will be equal. Also, this 1 Newton will be equal to T2 sine theta. Okay, so let's call this equation number 1 and call this equation number 2. Divide equation number 2 by equation number 1. So left by the left and right by the right. So I will write 1 divided by 2. 1 divided by 2 equal to T2 sine theta divided by T2 cos theta. T2 cancels. So tan theta, sine over cos is tan, right? Tan theta equal to half. That means theta is tan inverse half, which comes out to be 26.565. So I'll write it 26.6 degrees. Now second part is to find the tension as well, right? So I will write tension here as T2. I can use any one of them. Let me use this one. Okay. So T2 will be 1 divided by sine theta, right? Equal to 1 divided by sine. I will not use 26.6. I will write tan inverse inside. Tan inverse half. That will give me an exact value of T2, which comes out to be 2.23606. So I can write this as 2.24 Newton is the tension in BQ. Question 5. Two particles P and Q of masses 2m and m respectively are held at rest in the same vertical line. Okay. The heights of P and Q above horizontal grounds are 1 meter and 2 meters. So P is 1 meter. This is ground. And this is 2 meter above the ground. That means this is also 1 meter. Okay. P is projected vertically upwards. So this P is projected upwards vertically with 2 meters per second. At the same time, Q is released from rest. Release from Z, rest with 0 meters per second. Okay. Find the speed of each particle immediately before they collide. So, suppose they collide here. Let's call this distance x from the bottom. That means this distance will be 1 minus x, right? Since they are simultaneously released, yeah, that's what they're saying, at the same time. Yeah, somewhere here, ports, at the same time, yeah. That means this travel of 1 minus x by q is same as x by p. But time is exactly same for both. Let's use the relationship s equal to ut plus half at square, because the time taken by p to reach this point and q to reach this point is exactly same. Okay, so for p first on this side, for q on this side. Okay, so s is for p, s is x, it went up by x meters, so x is equal to 2 is its initial speed, t is t time, we don't know how much time it takes, plus half, since it is going against gravity, so minus 10 will be the acceleration and t square. So x comes out to be 2t minus 5t square. For u, it will be 1 minus x equal to u is 0 times t plus half, and this time it is going with the gravity, so it will be positive t square. This can cancel here. 1 minus x is equal to 0 is gone, 5t square. Okay, so this x and this x are exactly same x, right? So we can substitute 2t minus 5t square in place of x in this one. So 1 minus 2t minus 5t square is equal to 5t square. So 1 minus 2t plus 5t square equal to 5. Both have 5t square, they can cancel out. So 2t becomes 1, t becomes 1 over 2, which is 0.5 seconds. So they collide after 0.5 seconds. But the question was, find the speed of each particle. So for that we will use this formula, v equal to u plus at, and for particle p, vp will be 2 meters upwards plus minus 10, yeah, minus 10 will be because it is going up but it is being decelerated by gravity, and time is 0.5 seconds. Okay, so it comes out to be 2 minus 5 equal to minus 3 meters per second, which means it went up and it was returning after 0.5 seconds. Now VQ equal to 0 plus, this time positive 10, it will speed up, and it was, sorry, 0.5, right, 0.5 seconds. So it will be 5 meters per second downwards. But since this is faster and this is slower, both are going in the same direction, okay? 5 meter per second downwards, because we release it downwards. So it comes later and collides with the particle P. So the question was, what were the speeds? So for P, the speed was 3 meter per second downwards. Q was also 5 meters per second downwards. Okay. What is the second part? It is given that immediately after collision, the downward speed of Q, this Q, is 3.5 meter per second. That means it reduces. Okay. Find the speed of P at the instant that it reaches the ground. Okay. So we don't know at what height they collided first. So let's find x. We can find x from here. Yeah, let's find x. X is equal to 2 times 0.5 was the time we got, minus 5 times 0.5 square. So 2 times 0.5 will be 1, minus 0.25, and minus 5 times 0.25 will be minus 1.25. So it is minus 0.25. Are you sure? 2 times t, 5 times this, 0.25 minus 1. Yeah. That means they don't collide above P. They collide down here, somewhere here, 0.25 meter down, 0.75 meters above the ground. That's where they collide. So S becomes 0.25 for us. That means, keep it in mind, S is 0.75. When they collide, they have to be at 0.75 meter above the ground. They have to cover this to reach ground. Okay, this is what we'll keep in mind. But first, we will use momentum to find their, whose momentum, whose point P's speed after collision. Okay, for that one, we'll write m1 up, that is the mass of P, equal plus m2 uq equal to m1 vp plus m2, rather let's write p also here. This is q, this is also p, and this will be mq vq. Okay, so they're asking for p, so that means we have to find this speed. Okay, so masses of p and q, what are they? They are 2m and m. 2m is p. Okay, so 2m, this one, up, the speed of p is 3 meters downwards. mq is m, just m, and its speed is 5 meters downwards. mp, which is again 2m, we don't know v, let's call it vp, plus m2, which is m, and vq, they have given that its speed is 3.5. So this becomes 6m. First of all, let's cancel all the m's. We can divide the whole equation by the same m so that these m's are gone. So we're left with just 6 here, plus 5 equal to 2 vp plus 3.5. 6 plus 5 is 11, minus 3.5 will be 7.5 equal to 2 vp, and then we can get vp equal to 7.5 divided by 2, which is 3.75, and that makes sense. It is faster than q, so it will reach ground, but the distance it has to travel is 0.75 meters. That's what we said, right? So we want to find the speed at which it reaches ground. So we can use again speed, right? So v square equal to u square plus 2as. Okay, this is the speed of the ground, v square. U is 3.75 plus 2 times, it is going down and speeding up, so we'll write positive because v is also downwards, u is also downwards, so it will be positive 10, and s is 0.75. So v will be square root of this 3.75 square plus 20 times 0.75, which is 15. Let's put this in a calculator and see how much is the speed downwards. By the time I find this, I would request you to like this video, because this is the first solution video on YouTube of this particular paper. Share this with your friends and subscribe to Math United. What I'm getting is 5.3909646. I can write 3 significant figures, 5.39 meters per second. This is the speed with which it collides with the ground. Question number 6. A particle P travels in a straight line starting from O, straight line from O with a velocity 6 meters per second. The acceleration of the P, the time leaving, is a meter per second. A is given as these two equations from 0 to 1 differently, more than 1 differently. Find the velocity of P at t equal to 1. So it is equal to 1 here. That means we'll apply this particular equation. So they're asking velocity, not acceleration. So we'll have to integrate with respect to time, acceleration with respect to time, which becomes minus 1.5 outside and t to the power half dt. So v equal to minus 1.5 t to the power half plus 1 divided by half plus 1 plus c. It is equal to 1.5 t to the power 3 over 2 divided by 3 and multiplied by 2 on top. 3 over 2. Denominator of a denominator becomes numerator, so I'll write here. So this times 2 and this 2 cancels here. So answer is minus t to the power 3 over 2 plus c. Now, they have already said that it travels in a straight line. U is 6 meters. We are using the first equation, right? At 0, the first equation is applicable. So I can use this. When time is 0, speed is v is 6 meters per second. That's what I will use here to get c. So v is 6 equal to minus time is 0 to the power 3 over 2 plus c. So that becomes c equal to 6. So this equation here becomes v equal to minus t to the power 3 over 2 plus 6. Right? What they're asking, at 1, what will be the velocity? So at t equal to 1, it will be v equal to minus 1 to the power 3 over 2 plus 6. Minus is outside, 1 to the power anything is 1 plus 6. That will let it be, and that comes out to be 5 meters per second is the speed of this one. Alright. Given that there is no change in velocity of p when t is equal to 1, that means whatever is the speed with this particular equation, same remains in the second part also at t equal to 1. After that it may change, but at t equal to 1 it is still 5 meters per second. That's what it says. Find an expression for the velocity of t is greater than 1. So let's use, which will be useful. At t equal to 1, velocity is 5 meters per second. This will be useful. And again we have to find the expression for velocity from acceleration. So we'll again integrate the equation of the second part. 1.5, let me remember this, 1.5 t to the power half, yes, and is positive, minus 3 t to the power minus half. Okay, that is acceleration. We have to again integrate with respect to time. So integration of acceleration is velocity. This will be 1.5 t to the power again 3 over 2 divided by 3 over 2. First thing first, 2 times 1.5 is 3, so cancelled out. Okay, minus 3 t to the power minus half plus 1, positive half, divided by positive half plus c. Okay, so now for this c we'll use the fact we just collected. So at t equal to 1, v is 5 meters per second. So v is 5 equal to, this is cancelled, t is 1 to the power 3 over 2 minus, it is 6, t to the power, t is 1 again, power half plus c. This is 5 equal to 1 minus, this is also 1, so 6 plus c. 1 minus 6 is minus 5, goes to the other side, 5 plus 5 equal to c, 10. So our expression they are asking for velocity will be t to the power 3 over 2 minus 6 t to the power 1 over 2 plus 10. This is our answer. Let's see if there is a C part, and there is one. Given that the velocity of P is positive for t is less than equal to 4. T is less than equal to 4 positive. That means our equation here is positive from 0 to 4, including both of them. Okay. Alright. Positive for t is less than 4. After 4 it becomes negative. That means find the total distance traveled between t equal to 0 and t equal to 4. Okay. So there is no change in direction, so that becomes easy for us. So we will find the displacement from 0 to 1, 1 to 4 in two parts, and we'll find the total distance traveled. And for displacement we have to integrate what we got earlier again. The integration of the velocity is displacement. So first we'll get up to 1, which was the first equation which we got here. This was the equation. V equal, let's do it here only. Integration of v dt equal to from 0 to 1, right? Let me confirm once more. Yes, 0 to 1. This is applicable. 0 to 1 minus t3 over 2 plus 6 dt. Okay. So, which is displacement in this case. Since direction has not changed, the displacement is equal to distance. We don't have to worry about it. So, minus t3 over 2 plus 1 over 3 over 2 plus 1 plus 6t plus c from 0 to 1. And we don't have to find c in this case because c will be cancelled out very soon. Okay. So we'll substitute 1 and 0 one by one in this. So, and simplify also. So let me simplify this. Minus t to the power 3 over 2 plus 1 is 5 over 2. And t for me is 1, which I'm substituting right now. T to the power 5 over 2 divided by 5 over 2 plus 6 times t, which is 1 in this case, c minus t to the power, oh, this was minus, I did not put minus. It was minus, right? Yes. Okay. So 0 to the power, anything is 0, so there is no need to write, but let me write. Doesn't matter because it can become 0. 6 times again 0 plus c. This c and this c cancel out. This is 0, this is 0. That means this is the only displacement we have in first 1 second. So it is how much? Minus 2 over 5, because 1 to the power anything is 1. So minus 2 over 5 plus 6. And 6 minus 0 0.4 will be 5.6 meters. This is the displacement from 0 to 1 second. Now, from 1 to 4, we have different equation, which was this one. And this is what we are going to use for 1 to 4 seconds. T to the power 3 over 2 minus 6 t to the power half plus 10 dt will be the s from 1 to 4. Okay, so we will write this t to the power 5 over 2, because 3 over 2 plus 1, that's what we did previously, divided by 5 times 2 minus 6 times t to the power 3 over 2 over 3 times 2 on top plus 10 t plus c from 1 to 4. And now we will just substitute 1 and 4 in this and we'll get it. So let's do it. T is 4 for us. So 2 over 5, 4 to the power 5 over 2 minus 6 and 3 can cancel. 2, 4 to the power 3 over 2 and one more 2. So it becomes 2 times 2, 4. Plus 10 times 4 plus C minus, I substitute 1 now. 2 over 5, 1 to the power 5 over 2 minus 4. 1 to the power 3 over 2 plus 10. 1 plus C cancel out. Okay. So 2 over 4 to the power, okay, first of all this one. 2 to the power 5 over 2 will be how much? 32? Yes. I can do it mentally, but you can use your calculator, please. 32 times 2 is 64 over 5. This is 4. This will be 8. Square root is 2. Cube is 8. So 8 times 4, 32. Plus 40. Minus. This minus. Let's keep this bracket. 1 will be 1. So 250, 0.4. Minus 4. Plus 10. Okay. So 10 minus 4 is 6. 6. 0.4. 6.4 rather. Positive, right? I hope I'm not making any mistake here. Okay. So 64 divided by 5 will be how much? 12.8. Minus 32 plus 40 minus 6.4 I got from this. 6.4. Okay. So 12 minus 6.4 is 6.4. 40 minus 32 is 8. And we get 14.4 meters. So total distance they were asking, right? Let's say. Given that the velocity is this, find the total distance. So we will write here now, total distance from t equal to 0 to t equal to 4 will be 14.4 we got here, 14.4 plus 5.6 we got earlier, which is 20 meters. This is the total distance. I hope it was 5.6. Here it was 5.6. That's the answer. Question number 7. Two particles A and B of mass 0.2 and 0.3 kgs respectively attached to ends of the light inextensible string. The string passes over small fixed pulley, smooth pulley, okay, bottom of rough plane. Okay. This is a rough plane, which is inclined at theta degree. So this one is rough. Okay. And sine theta is 0.6. Particle A lies on the plane and particle B hangs, okay, below 0.25 meters above the ground. Okay, the string between A and pulley B is parallel to the line of greatest slope. Okay, and the coefficient of between A plane A is 1.125. Okay, usually the coefficient of friction is not more than 1, but they're saying it is 1.125. That is interesting. Particle A is released from the rest. Find the tension in the string and the magnitude of the acceleration of the particles. So let's find acceleration first. Okay, for acceleration we'll use our usual equation, which is that net force is the applied force minus resistive force. Okay, so mass in this case are both 0.2 and 0.3, so 0.5. Acceleration is A, we don't know it, but applied force will be the weight of this particular mass. So 3 Newton is 1 applied force. There is one more applied force. The weight component of this is also downwards. It will also break it down. So there are two applied forces kind of. Since this will be more, that's why this tension will exist. So this force is how much? 2 sine theta. So 2 sine theta is another force which is bringing it down. Now, what about the resistive forces? There is only one resistive force, which is the friction between A and this particular surface. And that will be minus mu and normal force. But we need to find what is that normal force. Let's find that normal force. This will be 2 newtons downwards, the weight of this particular mass. The component in this direction will be 2 cos theta, and that will be equal to the normal contact force 2 cos theta. So in place of mu r, we can write minus, mu is given, right, 1.125. And resistive force, we just got it, 2 cos theta. Okay, and now we can write 0.5 A is equal to 3 plus 2, and sine theta value is given 0.6. And this cos theta can also be found, and there's no need to find any angle for this. You can write this one as 0.6 this side, right? Can I write 3 here and 5 here if this is theta? Isn't it? Sine theta is 3 over 5 is 0.6. That by Pythagorean this comes out to be 4. So cos theta will be 4 over 5, which is 0.8. So this is smartly, we can do it without finding the angle. So I didn't write A here. 0.5 A is equal to 3 plus 2 times 0.6 is 1.2 minus 1.125, 2 times 0.8 now. Okay, and A, we want to find acceleration, right? So we'll do this 4.2 minus 1.125, and this will be 1.6, and divide by 0.5, which was the coefficient of A in this case. That will give us the acceleration. By the time I find this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is acceleration equal to 4.8 meters per second square. Additionally, they asked us to find the tension in the string, and for that we will focus on this particular weight, which will be, the body diagram will be like this: 3 Newton downwards, tension upwards, and that will give us the tension by using this formula, MA equal to F applied minus resistive force. Mass, because we are concentrating only on 0.3 kg, so it will be 0.3. Acceleration we just got 4.8 equal to applied force, because it's going down, so 3 becomes applied force and tension becomes resistive force. So T will come this way, becomes positive, and this will go to the other side, 0.3 times 4.8 negative, which comes out to be 1.56 newtons. That's the tension in the string. Okay, there is B part also, which says when B reaches ground, when B reaches ground means 0.25 meters down, okay, it comes to rest. When B, okay, it comes to rest. Wow. Usually it is not, right? It collides with the ground, but they say it comes to rest. That means the force upwards is more than the force downwards, okay. Find the total distance A traveled down the plane from where it is released until it comes to rest. This is a little confusing. How can it come to rest? Let's assume that they're saying that it comes to the ground, hits the ground, but does not go anywhere, just stays there. That's what we can do. Otherwise it can't come to rest, because we have an acceleration here, 4.8 meter per second square. It will not come to the rest by itself, okay. All right, so what they mean to say is that the lower body comes to the ground, stays at rest, and the upper body will keep on traveling down, okay. But the force which was 3 Newton, which was bringing it down, is no more there. So only the one which was the other one, 2 sine theta, is the only force, and mu r, these two are the only forces being applied on the second body, and that's why it will come to rest. That's what I can understand from this. All right. So first, when 0.3 kg comes to the ground, they have already traveled 0.25 meters. So 2.5 meters is already traveled. We have to find the remaining distance that it travels on its own. So let's go to here, this space, and we can see that now this is the only body that is traveling, which is 0.2. The acceleration will be different now. It will not be same which was there earlier, and which will be equal to the applied force, which is 2 sine theta downwards minus 1.125 2 cos theta. Yeah, that was our normal contact force. Right? So acceleration comes out to be 2, and sine theta was 0.6. Yeah, 0.6. So 2 times 0.6 is 1.2 minus 1.125. 2 times 0.8, that's what we got cos theta as 1.6, divided by coefficient of A this time is 0.2. So it comes out to be minus 3 meters per second square. Okay, and now we have to find, with this acceleration, how much will it travel down before coming to rest. But we should know the velocity also, with which, that's what I was saying, it is not possible that it will reach ground and go to comes to rest. It is not possible. So we will see v square equal to 2as plus u square. This is how we find the velocity in first case. Case 1, when this particular body was traveling this way. So 0.25 meters was the distance they traveled. So s is 0.25. Acceleration in that case was 4.8. So 2 times 4.8. It started from rest, and we'll get v. So v becomes 2 times 4.8 is 9.6 times 0.25, which is 1/4 square root of 2.4. So I'm not going to evaluate this, because this is what we are going to use to find the second part here, and that will be here. We will use the same formula again, but they said the upper body A comes to the rest, so it will be 0 square 2 times acceleration we just got minus 3 meters per second for second case. This is case 2, when B has reached ground and A is traveling on its own. So 2a, A is minus 3, S is we want to find out, but U we know now it is the V of the previous case, square root 2.4 square, and we know that square and square root can cancel out, so it will be 2.4. So minus 6s 0 equal to minus 6s plus 2.4, and 6s can come to the left side. 6s equal to 2.4. S is 2.4 divided by 6, which is 0.4 meters. Got it. This was 0.25 meters earlier, now it is 0.4 meters. Total distance is 0.65 meters.